Quick note, this is an AI-assisted, 5-minute recap of an NVIDIA Keynote at Computex 2026, made for learning, and it heavily condenses a 28-minute talk. Kevin Deierling, who runs networking at NVIDIA, says 3 transformations are hitting computing at once: accelerated computing, generative AI, and now agentic reasoning. Together they force a rethink of the data center, from a cost center that merely runs IT, into an AI factory built to generate tokens and revenue. Why do we need accelerated computing? Because Moore's law, in its full sense, has ended. Transistor counts still double, but no longer at the same power and cost. The physics beneath it, Dennard scaling, broke down around 2005. So simply waiting for faster chips stopped working, and computing had to be reinvented. The fix is massive parallelism: rewrite single-threaded apps across thousands of GPU cores, and give the CPU one new mission: keeping those GPUs fed and busy. Meanwhile, token demand is exploding. Model sizes have grown roughly 10 times every year, and that steep curve shows no sign of bending. Then reasoning arrived. With mixture of expert models, an AI can generate 100 times more tokens internally just to produce one output token, and agents push that even higher. So NVIDIA races to cut the cost per token: more tokens per watt, more tokens per dollar, shrinking precision from 16 bits down toward just 4. To deliver tokens efficiently, the entire data center is redesigned as an AI factory, optimized across the whole stack, not one chip at a time. Jensen Huang calls it a 5-layer cake: energy at the bottom, then chips, then infrastructure, then models, and applications right at the top. The key is extreme co-design, optimizing within each layer, and up and down between them all at once. Let's climb the cake from the bottom. Energy is foundational. It caps how much work the factory can do. And you usually can't just order more, so you have to use every watt wisely. He borrows a Taipei image: like the Feitsui Dam storing monsoon rain for dry spells, an AI factory should store energy instead of letting it spike and crash. Training is spiky: thousands of GPUs surge together, then pause. A factory operating system smooths that curve, packing 40% more GPUs and tokens per gigawatt. Up a layer: chips. NVIDIA insists it's now an infrastructure company, not a chip company, because a single chip, however good, is never enough on its own. 7 chips are co-designed together. The Rubin GPU pairs with the Vera CPU over a fast, cache-coherent link, scaling up inside the rack with NVLink. Then Spectrum Fabric, with ConnectX and Bluefield, scales it out across the whole data center, delivering 10 times the tokens at 1/10 the cost each. Systems still aren't enough, they must be knit together. NVLink joins 72 GPUs in a rack, using copper where possible. It's cheap, reliable, and draws no power. But copper now reaches only a few meters, so GPUs are crammed close, which forces liquid cooling and high-voltage DC power to carry away all that heat. Between racks, co-packaged optics place the light engine right beside the chip, keeping signals clean and saving tens of megawatts, power redirected straight into making tokens. All this bandwidth matters because agents have arrived. An agent, he jokes, is AI eating its own tail. Instead of a human prompting it, the AI feeds prompts back to itself. And AIs are impatient, far faster than people, forming loops where models talk to models, thinking, planning, reading documents, and calling tools. The Vera CPU is built for exactly this: about planning, writing programs, and summarizing results, with open Nematron models and Bluefield chips keeping everything secure. Thinking needs memory. Agents need short-term memory, the KV cache, and long-term memory held in files, objects, and searchable vector databases. So NVIDIA built a new class of AI storage, CMX and STX, for those 2 kinds of memory, yielding 5 times the token throughput and far better efficiency. At the models layer, the same co-design runs today's models much faster, 30 times quicker on a recent DeepSeek model with Blackwell, and faster still on Rubin. Applications are the icing on top. CUDA-X libraries accelerate everything: chip design, fluid simulation, decision optimization, and large-scale data processing. And none of it works without partners, many of them right here in Taiwan, the ecosystem that turns co-designed chips into real, running AI factories. The takeaway: agents are new digital workers that plan, reason, and act, and accelerated computing plus extreme co-design is how nearly every business will soon run.